All right, let's graph g of x equals cosecant x. Now, whenever I graph cosecant or secant or cotangent, I like to view it from the point of view of its reciprocal. So cosecant is 1 over sine x. And so what I'm going to do is I'm going to graph sine x as kind of like my guide to graph cosecant x. So what do we know about sine x? Well, it's regular sine x starts at 0, 0. It peaks out at 1. It bottoms out at -1. Period of 2 pi. So let's graph that out. Okay, 0, and then it peaks out here, and then it re-hits, and then it bottoms out, and then repeats. And then the reverse is also going to be true, so let's draw that out. Okay, sine. Now, this is, again, like a rough draft or a guide, if you will. Not even a rough draft, but more of a guide. Because if you saw my video on secant, what's going to happen is very similar stuff. Okay, very similar stuff. Now, what's very important that I understand here is I have a x in the denominator, which means there's going to be a point, literally, and several of them where sine of x is going to equal 0. Well, whenever sine of x equals 0, that means cosecant has a vertical asymptote. Well, that just means that sine x is 0 at these moments right here where it crosses the x-axis. So you are a vertical asymptote. You are a vertical asymptote because x equals 0. Because sine x equals 0 at these moments. So vertical asymptotes here where it crosses the x-axis, and vertical asymptote here where it crosses the x-axis. Now what I have, and again, very similar to secant, is I'm rotating what appears to be like parabolas. Where do these parabolas start? Well, right here, okay? Why do they start right there? Because it's following the pattern of its reciprocal. So this is basically going to look like it has a parabola here, okay? This is going to kind of go downward. This is going to go upward, and this is going to go downward like so. Okay? So if I was a better artist, this would look a lot prettier, but I'll give myself a little pat on the back. This ain't so bad.